Hello, Advanced Algebra class. Today we're going to talk about systems of linear equations. This is section 5 in your book. We're going to solve by elimination. So let's take a look at a problem here. We have a system of equations. Notice we have x minus 3y equals negative 3. We have negative x plus y equals negative 1. So what you should notice here is the x term and the other x term. This has a coefficient of 1. This has a coefficient of negative 1. I want you to think for a moment, what happens when you add 1 plus negative 1? What is 1 plus negative 1? It's 0. So if we add these two equations together, watch what happens. X plus negative x, that equals 0. So that is eliminated. That's why this is called elimination. Negative 3y plus y, that is negative 2y. Negative 3 plus negative 1, that is negative 4. All right, so let me rewrite this a little bit. We got negative 2y equals negative 4. To solve for y, I'll divide both sides by negative 2. And I get y equals positive 2. A negative divided by a negative is a positive. So y equals 2. Now think about how we can find x. What can we do to find x? Well, I can plug y equals 2 back into my equation. Either equation will work. Which one do you think is a little bit easier? I think this bottom equation might be a little bit easier here. So let's do that now. Oh, excuse me. Let's try that one more time. Nope, that's not going to work. So looks like this when we do that. Negative x plus y, which is plus 2, equals negative 1. We will subtract 2 from both sides, minus 2 and minus 2, and we get negative x equals negative 3. So if negative x equals negative 3, then x must equal 3. So there you go. We have our ordered pair, which is 3, 2. 3, 2. That is solving a system of equations by elimination. You want to find a term where the coefficients have the same absolute value. So 1 and negative 1 have the same absolute value. So I can add here because they are in fact different signs. 1 and negative 1, when you add that, they equal 0. And then we are left with just our y term. We can solve that our equation. Once we solve that equation and we have our y value, we can plug that y value back into either equation and solve for x. Let's take a look at another example. Here I've got 4y equals 12x plus 4, and I've got 4y minus 8x equals 12. So what do you think we can use to eliminate here? Or what do you think we can eliminate, the x or the y? Notice the y is 4y and 4y. Now I want you to notice something about the x as well. This x term is on the right side of the equation. This x term is on the left side of the equation. I'm going to eliminate my y term. But first, I'm going to make sure that the top and the bottom equation have the same terms on both sides. Let me show you what I mean. So if I subtract 12x here, that leaves me with 4y minus 12x equals 4. And then my bottom equation is 4y minus 8x equals 12. Now, I didn't have to do this, but it just minimizes my risk for making a mistake. When all the terms line up on the correct side, not on the correct side, but all the terms line up on the same side of the equation, just saves me an opportunity to make a mistake. So 4y and 4y. Should I add or subtract here? I'm going to subtract. So when we subtract, everything in this bottom equation is going to be subtracted. So 4y minus 4y, that's going to be 0. Negative 12 minus 8x. Now, when you subtract negative 8x, that's the same thing as plus 8x, right? So negative 12x minus negative 8x, that's going to be minus 4x. And then 4 minus 12 is negative 8. We'll divide both sides by negative 4, and we get x equals 2. Once we know x equals 2, I can take x equals 2 and plug it into either equation. It doesn't matter which one. I'm going to plug it into this top equation up here. We'll see what that looks like. 4y equals 12 times, instead of x, I plug in a 2, plus 4. So 4y equals 24 plus 4. 4y equals 28, and hopefully you can know that y is equal to 7. 4 times 7 is 28. So there's my x, there's my y, and I can write this as an order pair, 2, 7. Remember, the solution to a system of equations is the point where these two lines intersect on the graph in the Cartesian plane. So I want you to take a moment, work these two practice problems, write them down on a piece of paper, pause the video now. These are your two practice problems for this video. The first two practice problems for this video. Pause the video now and work these practice problems. All right, so here's the solution. 7x plus 2y equals negative 19. Negative x plus 2y equals 21. I've got a positive 2x and a positive 2x. So I'm sorry, a positive 2y and a positive 2y. So I can subtract and eliminate my y terms. So 7x minus negative x, that is 8x. Negative 19 minus 21, that's negative 40. We solve for x, and we get x equals negative 5. You then take x equals negative 5. You can plug it into either the top equation or the bottom equation. I plugged it into the bottom equation, and you'll see that work here. The opposite of, or negative, negative 5 is positive 5. And then we subtract 5 from both sides. We end up with 2y equals 16. Solve for y, we get y equals 8. So our order pair is negative 5, 8. That is where these two lines intersect in the Cartesian plane. All right, on this problem, I hope you noticed that y had a coefficient of 1. This y had a coefficient of 1, but I also hope you noticed they were on different sides of the equal sign. So this y is on the left side, this y is on the right side. So I want to make the terms kind of line up. So to do that, I subtracted y from both sides in this bottom equation. I was left with the same top equation, 3x plus y equals 5, but my bottom equation became 6x minus y equals 4. Okay? Remember, the term you're going to isolate, or the term you're going to eliminate, that needs to be on the same side of the equation. It just helps you not make a mistake. So I have different signs here, y and negative y, so I can add. 3x plus 6x is 9x. 5 plus 4 is 9. The y's are eliminated. X equals 1. I take x equals 1. I sub it back into either equation. I chose the top equation. You could have just chosen the bottom equation as well. So 3 times 1 plus y equals 5. We isolate y and we get y equals 2. So 1, 2 is the intersection point of these two lines. All right, let's take a look at this system of equations. On this particular problem here, I don't have any coefficients that are either the same number or the same number with different signs, so like positive 2 and negative 2. However, I do have a 4 and a negative 8. So think about the multiples of 4. 4, 8, 12. Well, I can make a 4 look like an 8, and I can do that by multiplying by 2. If I take 4x minus 3y equals 5. And I take that entire equation and I multiply the whole thing by 2. I end up with 8x minus 6y equals 10. Then we can take a look at our bottom equation. Negative 8x plus 6y equals negative 10. Okay. So now we can eliminate the x term here by adding or subtracting. We can add 8x plus negative 8x is 0. Negative 6y plus 6y is 0. So the left side of the equation is 0. 10 plus negative 10 is also 0. Okay, so this is kind of a different kind of answer. 0 equals 0. Both my terms got eliminated, both my variables got eliminated, and the constant got eliminated as well. We end up with a true equation of 0 equals 0. So what do you think is going on here? This is a line on top of a line. These are identical lines. So these are consistent and dependent. So that was a little bit different there. All right, let's look at another example. This will be the last example before you work a couple more practice problems. Let's look at our variables here. We've got 8x and negative 16x. We've got negative 6y and 7y. Think about what we could eliminate. Think about the multiples of 8. 8, 16. So if I make that 8x look like 16, I can eliminate my x term. So I can take that entire equation, I can multiply it by 2. When I multiply that entire equation by 2, I get 16x minus 12y equals negative 40. My other equation did not change. Negative 16x plus 7y equals 30. Think about whether we add or subtract here. We would add 16x plus negative 16x is 0. Negative 12y plus 7y, that's negative 5y. Negative 40 plus 30, that is negative 10. Okay, you can divide both sides by negative 5, and we get y equals 2. Once we know y equals 2, I can find x by taking y equals 2 and plugging it into either equation. I'll plug it into that top equation. 8x minus 6 times 2 equals negative 20. And I'll save you guys the work. There you go. We isolate x and we get x equals negative 1. So we have an order pair of negative 1, 2. All right, take a crack at these two practice problems. Pause the video now. All right, the first practice problem here, this bottom equation. I can multiply the bottom equation by 2, and that allows me to eliminate my y term. Let's see what happens here. The entire bottom equation gets multiplied by 2. It leaves me with 12x plus 10y equals 4. So now I've got negative 10y in the top equation, positive 10y in the bottom equation. I can add these two together. I'm left with 4x equals 28. Divide both sides by 4, and x equals 7. I can take x equals 7, sub it into either equation. I subbed it into the bottom equation. I isolated y, and I get y equals negative 8. So 7, negative 8 is the solution.